Hello grade 9s, this is Mr. Miller and welcome to lesson 4.2 on scale diagrams. So in number 1 we're going to focus on calculating the missing value in each proportion. This is an important skill before we can get to solving problems involving scales for scale diagrams. So the first method I'm going to give you is sort of a surefire method that you would have done last year in grade 8. And it's this method of cross multiplying the two numbers that are diagonally across from each other and dividing by the third number in the proportion. So in this case that means we're doing 1 times 624. Those are the two numbers that are diagonally across from each other. And then we're going to divide by the third number in the proportion, which is, in this case, 8. And when we get the value here, 1 times 624 is just 624, and we divide that by 8, we get 78. So this 78 is the number that is the missing value, goes in that box. So this is sort of the surefire method. It's if you're unsure how to do it otherwise, this will always work. But there are some cases where it's a lot simpler. So for instance, if you're looking at this in terms of equivalent fractions, it means that when you multiply the numerator and denominator by the same number, that gives you an equivalent fraction. Of course, you know that 1 times 25.2 is what will give you 25.2. So if I multiply the 50 by 25.2 as well, then this will give me the missing number that should go in that box. So I just have to do 50 times 25.2, and that gives me 1,260 that goes into that box as the missing value we're looking for. And again here, same thing. 1 times 58 will give me 58, so I can do 0.6 times 58, and this will give you the missing value that should go in that box. So 0.6 times 58 is equal to 34.8. Alright, next, take a look at the next three. This is going in the opposite direction. So we've got the equivalent fraction, we want to work backwards to here, backwards to the 1. So since we're moving backwards here, we're actually dividing the 15.3 by 15.3 in order to get 1. And so I'm going to do the same thing to the denominator in order to get that equivalent fraction. And in this case it's 1224 divided by 15.3, and this gives us 80 as the value that goes in there for the missing value. Back to this one here. I don't really know what number multiplies 75 to give me 6450, so I think I'm going to go back to that surefire method of cross multiplying the two numbers that are given that are diagonally across from each other and dividing by the third number in the proportion. So this gives me 1 times 6450, and dividing by 75, this will give me my answer, and then I'll put that into the box here. So 1 times 6450 is 6450, and if I divide by 75, then this gives me 86. So this 86 is the number that should go into the box. And finally, I can see that going back to 1 from 5.6, dividing by 5.6 will accomplish that, so I can divide the bottom by 5.6 as well, and this will be the value that goes into the box, 1.68 divided by 5.6, and that's equal to 0.3. So, just taking a look over the examples that we've done here in parts A through to F, what you'll notice is that in each case we had a proportion, so that's a fraction equal to a fraction. The fraction on the left was always 1 over something. 1 over 8, 1 over 50, 1 over 0.6, and so on. The reason that the numerator was always 1 is because this is often how you will see scales written for scale diagrams. They'll be written in the form 1 centimeter represents something. So it can be, for instance, 1 centimeter represents 8 centimeters, or 1 centimeter represents 50 centimeters, or 1 centimeter represents 0.6 centimeters. It can either be a reduction, so 1 centimeter on the diagram can represent something larger, like 8 centimeters, or it can be an enlargement. 1 centimeter can represent something smaller, that's only 0.6 centimeters of actual size. Each case will be a little bit different. But scales often have that characteristic that they have 1 centimeter representing something. If the units are not written as they're not written here, you have to keep it the same. So that means that 1 centimeter would represent 75 centimeters. Or if you want to work in millimeters, you could say 1 millimeter on the diagram could represent 75 millimeters. So here's a situation where we are given a scale, and the scale is 1 to 20, which can also be written as a fraction, 1 over 20. The 1 in the numerator, this is the size. This is the size on the diagram, and the number that goes in the denominator is the actual size. So we're going to do the same thing on the other side of the equals and setting up this proportion. We want to calculate the actual length of each object. So what's given to us here is the size, the length of this scooter being 3.5 centimeters on the diagram. We want to know actually how large it is, or how long it is. And so you can see here that, you know, multiplying the top by 3.5 will change the 1 into 3.5, so we can multiply the bottom by 3.5 as well. So 20 times 3.5 will give us our answer, which is 70 centimeters, and that's how long the scooter is, the actual size. So let's take a look at this situation, which is a little bit different. We have a scale of 1 to 0.3, which I can write as a fraction, 1 over 0.3. Again, the number that goes in the top, this is the size on the diagram. And the number that goes in the bottom is the actual size. And so a little bit different from the last one. The last one, the diagram was a reduction of an object that was bigger. This is an enlargement of an object that is smaller. So the size on the diagram is 30 millimeters long. We'd like to know what is the actual length of this housefly. And so to get that, we can simply multiply the numerator and denominator by the same number, 30, because we know that 1 times 30 gives us 30. 0.3 times 30 will give us 9 millimeters, and that is the actual length of this housefly. Now let's talk about scale factor. If you want to calculate scale factor, what you can do is you can take this fraction and put it as 1 over, because we've been doing 1 centimeter represents whatever. And you know that dividing the top and the bottom by 53 will accomplish that. But often that fraction that we get, that 1 over, in this case it's 1 over 2, we like to take that and write it as a decimal. You know that 1 over 2, you can calculate its value by doing 1 divided by 2, which is 0.5. But just also note that if you were to do 53 divided by 106, 53 divided by 106, you also get the same result of 0.5, and both of these are the same, and this is your scale factor. So whether you change this into the form 1 over something, or you simply take the numerator and divide by the denominator. It doesn't matter, it's still the same thing. You're still going to get the same scale factor. So that's what we're going to do for the rest of these examples. Just speed things up. It's 0.9 divided by 15. This is the scale factor for the next one, 0.06. And again, I'm getting this just by doing 0.9 divided by 15. Okay, the next one we have is 17 divided by 850, and this is 0.02. The next one is 6.2 divided by 24.8, and that is 0.25, that's a quarter. Next one is 18 divided by 24, so that scale factor is 0.75. And the last one is 30 divided by 37.5, and this gives us 0.8. You can see that the scale factor, we had the denominator larger than the numerator. That made our scale factor always less than 1, which means that in each one of these cases, like even like the first one, 1/2, 1 centimeter representing something that's 2 centimeters long in real life. These are all reductions. If we had a scale factor that was larger than 1, it would be an enlargement. These are all reductions. Okay, let's take a look at number 4 now. It says that a driving distance is 650 kilometers. Distance shown on a map is 4 centimeters. So express this scale in words. So you can start off by writing 4 centimeters represents 650 kilometers of actual distance. And of course you want to reduce that, so you're going to divide both of these parts by 4. And so it's actually 1 centimeter that represents so let's just do this. 650 divided by 4 is equal to 162.5 kilometers. And this is what you'd see on a map typically. The scale is often indicated in a corner somewhere, and you'd see something like this written. 1 centimeter represents 162.5 kilometers. Okay, it's another way to write a scale. Now to get the scale factor, what we need to do is we need to change the 162.5 kilometers into centimeters. And so we need to multiply by 1,000, right? This is to convert kilometers to meters. And then we need to multiply by 100, which is going to convert the meters into centimeters. And so as a result, we're going to get a fairly large number. 162.5 times 100, or sorry, times 1,000 first, then multiplied by 100 is going to give us 4 zeros and then a 1625 out in front. So this is 16,250,000 centimeters. So that means that if you're writing this as a scale, you would write 1 over 16,250,000. And if we take 1 and divide by 16,250,000, we get approximately 6.2 times 10 to the negative 8. So this is a very, very small number. Basically, we're talking about 0.000000062. This is your scale factor. So this is a huge reduction. Of course, if you're taking something that's 162.5 kilometers long and reducing it down to 1 centimeter, that's quite a bit of a reduction. Anyways, there's your scale factor, and we've rounded that to the nearest tenth in scientific notation, and we also took a look at that number in just regular decimal form. So that's the end of the lesson. Here's your assignment at the bottom, and thank you for watching this lesson.